Hello everybody. This is a class on deep learning, and I hope you guys are all familiar with machine learning and the concepts behind the linear algebra and a little bit about matrices, how mathematics works around matrices. So in this class we will be focusing on platform in Python that would be utilized in using neural networks and the structures similar to neural networks, how they are proficient in learning, just like the way we learn in linear regression or multiple linear regression, logistic regression, and stuff like that. So we would let me tell you how we will go through it. So we would first learn about neural networks, so the structures of the neural network, how does that play a role into teaching. Then we would go into the math behind it, so uh, how each neuron is actually functioning in the structure, how do they learn, so what is backpropagation, which is the best method to the entire reason they learn so well. And then we will go around learning the NumPy package. So how would you use that? So that's mostly about matrix multiplication, division, addition. So that's most like a electronic gate. So you are trying to reach to an answer, and what procedure do you take in order to reach that? So that is the part that we would go through with using NumPy. So we'll learn how does that work. Once we know the basics about how the learning process comes in, we would go into optimization. So how do we decrease the loss, or how do we decrease the cost function, or what is the cost function, and what are the different optimizer like atom optimizer, or people use RailU. So how do they work? We would also go about different activation functions like softmax, RailU, tanh, and how each one of is different and could be used for a different scenario. Um, as we go on picking this, we would utilize a module which is TensorFlow to practice all of this, and because that's the one of the best packages I've used, and I would prefer for you to use that. And why do I say that? Is the recommendation is because Google is using it, and they have tested like thousands of applications with a huge amount of load on the application. By load I mean like number of people who use the application is huge. So it's tested, it's debugged, and it's perfect for us to be like free to use. So we would learn TensorFlow. So today's class would actually be in a little bit of introduction about TensorFlow and how they work, what are the different functionalities, and why is it even worth learning. So it's amazing. Okay, once we have learned about neural networks, we would go into learning about convolutional neural networks, which are built around images. So there are different type of data, and we use different models to treat different data. So convolutional neural network is really well when you perform it on image data, so 2D 3D data, and you could use we will see how that comes into play. Then we would go into recurrent neural networks. So they are used when you have sequences involved, time series, videos, noise, like not noise, like voice, and sensor data, and everything where there's a long range of sequence. Mostly everything in the world, I would say, is time series data, because it's stacked with it. But we would see how we break it down, and we can give like a chunks. So I'm not saying like cut down the video into images or cut down the time frame into like seconds or something, but you can give it like minutes and hours of stuff, and then it learns like on the batches. So we would see how that it's I hope we get to use it in some of the applications where you realize how crazy it is. And then we'll go into LSTM. So LSTMs are it's the same concept. So they are used for sequences, but they are more of a memory form. So obviously, the one of the biggest challenges that we faced, like pre 2015 or 14, was none of the models were able to memorize, not memorize, like they didn't have a memory of what they learned previously. So we would learn about LSTMs, where we would see that we have a choice of performing or building such functions that would be able to memorize what they learn, and then we would have the result based on those memories and not just like frame by frame detection, you know. So if I'm saying John was eating an apple and John felt very satisfied, so if I had to predict the word satisfied, John was, I could say anything in the blank. If I didn't know, it was related to the food, the apple that he ate, right? So you need to have the memory of the previous subject in order to say what would be John right now. So he feels less hungry, or he is like fill the dash, you know. So that's where LSTM comes, and we would see and learn about them. Then we would go a little bit about reinforcement learning. So that's a place where, so mathematically it has different concepts than rest of the neural networks, but why we would learn is because it is a part of deep learning, right? And here you don't use labels, so here nothing is labeled, you know. So you don't have to like give it dog or cat, or whether there was a wet road or a dry road, or like a series of like numbers or alphabets that you have to learn about. So here you are in an environment, and we would see how we gain reward and punishments from the environment by the tasks that we perform and how we perform. So it's very interesting, and we would learn because there are amazing applications that are being built around this uh, 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 process of learning. Then we would go into using web interfaces and building models and then placing them for other people to use. So obviously, when you would be proficient enough, when you have learned the how to train your models and stuff like that, you would want it to be presented. So your employer would want it not to sit on your laptop, but actually be utilized in the company. So in order to even while submitting your work, you would prefer it to be a complete demonstration of what it is capable of. And sometimes maybe that's not the end product, but that's the first that's the first click. So we would learn about how to make a Django or maybe a Flask web application based on we would start with Flask, and we would see how we can build an application, and then we would go into Django. Django is like more complex. It's not necessary to really learn Django, but we would go into the basics of from the start to the part where you can deploy and let anybody in any part of the world access to your application. Okay, so that's the highlight of the overview of what we are going to cover in the time to come. So all of this is going to happen on a platform, as I said, and which would be TensorFlow. So today we would look into basics of TensorFlow. So I've prepared this class for you, where we would see. So as I said, you should be aware of Python, the basics of Python, and you should be aware of machine learning in general, like how does it work. So even if you're not familiar, I would try to make it as simplified as possible because of first class, and I don't really want you to be feeling that you can't catch up. But try to leave your questions and like on the side, and I would try to answer as we go, most of them. So here's what we have done. The first thing that you see is packages to be imported. Is so the documentation what I've done is pretty easy. So you would have it, and it's easy to read step by step. Everything is being explained very well. So there's import TensorFlow as TF. So that's TensorFlow package that I've downloaded. I would send you the link where to download it depending on what operating system you're using. You could download that particular version. The second library here is NumPy. So NumPy, as I said, is a matrix library. We would use matrix multiplication, addition, division. We would use NumPy to do all of that. So all the math has been done here, just one library. So import warnings, this is just to remove some garbage from my screen. Basically, it helps you remove any errors that come, not error, like operating system warnings. So that's for that. So here what we are doing is, so this is once we have imported the library, the first thing that you want to do, so there are two parts of TensorFlow. So the first part is where you are building the 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 solid state of your model, which is not functional, like it doesn't do anything, but you make the structure, you know, like you make the boundaries. So you make the car, but you are not yet running it. Okay, you're making engine, tires, and everything, but you are still not running it. So the running part comes later. So in TensorFlow, everything is broken down in two parts. You have to create the structure, and then you have to decide a particular state where you want to run it. Okay, so here we are building the structure. So we are putting two variables, x1 and x2. We are saying they are TensorFlow constants. So, one has a value of 5, another one has a value of 6. So we have just initialized two variables. Just like, so why this is TensorFlow is totally built on C++, just like Python is in the under the hood, and it would utilize the similar techniques for you to perform the task. So here we define a variable and we initialize it and we say it's a constant. The next step is, what do we want to do with it? So say I wanted to multiply it. So I say let's multiply it by saying tf dot multiply. So there we just mentioned that the first value is x1, the second value is x2. Now some of the places you would see tf.mul, which is similar to multiply, but that's the previous version of TensorFlow. In the current version, you have to use multiply in complete. And then we save it to result. Then, as I said, so nothing has been performed. We are just creating a structure. So if you try to print this out, you would get this result, not 5 into 6, which is 30. So that wouldn't happen. Why it didn't happen? Because we have just initialized our variable and the structure. We have not run anything, right? So how do we run it? So we create a session. So inside this session, everything runs, right? So you have to create a session. You can name it whatever you want. You say tf.session, so the computer knows that you have created a session. Then you say print ses.run. So when you say you have named it ses, you run it, and what do you want to run in it? So you say I want to run this result in it, and as you do, and then you do session.close, because you want all your variables not to change and you don't want any of the data to be lost, so you get a final output as 30. So session run, session close, right? So this is a general way how TensorFlow works. So you create a structure just like creating a model, and when you say tf.learn or tf.fit, so that's when it actually starts the learning process, just like how you learned earlier in machine learning, right? So TensorFlow is similar when you're building the models. You have to initialize everything, the structures, the variables, and once you even sometimes the placeholders, and then once you have all of that in place, then you run it, right? Before that, nothing happens. Okay, there's no memory consumed, and I mean there's memory consumed, but nothing in running form, in changing form. So okay, so that one more alternative that I've described is, instead of doing all of that, ses.run and etc., you could also do with TensorFlow session as ses, print this. So because this is in a loop, you don't have to close it. It would automatically close once it is out of the loop. So that saves you a lot of time to type it all down. So usually this is how I prefer to do it. I just wanted to show you how it could be done also.